Okay, so now that we're finally sat down, after asking you nicely, I thought twice. Okay, what can you tell me about what you have learned so far this chapter? Just tell me.
Yeah, I don't know, like read the periodic table.
Atomic numbers.
Well, yes, atomic numbers are important. Why?
Because you need to know that to get your proton, your neutron, your electron.
Okay, well, I guess we'll go with that. Okay.
And two to a table.
Start your full. Okay, I want to do this slide, show you some examples of this, and then briefly get into the next section, and then we'll continue with the elements video. Okay? We just have the one gentleman gone today. Is that right? Because I took attendance already.
Got the virus.
Does everyone have this content that wants it?
Yeah, I got it. Oh.
Okay. Okay, we'll probably get to this individual in this video. And I want you to think of, well, I don't care if you think about it. Maybe you will, maybe you won't. But when this was discovered was, I believe, in the early 1800s. And what's so significant about that, as this Russian chemist, Dmitry Mendeleev or Mendeleev, how do you account for something that you can't see? And they will address that in this video, I believe. Okay. Dmitry, I think it's Mendeleev.
Wait, so then if you're named after a junior, are you a sophomore then, or what? Sorry. Did you ever ask him? If you're named after a junior, are you a sophomore? I saw that too.
And I used to know this on the periodic table where there are some elements, if it was arranged by atomic mass, that would be out of place. In other words, you would have a number greater than the element next to it would be less than that. I think iodine is like that. Element 53, because I believe tellurium is actually a little heavier than iodine, but because of the number of valence electrons that iodine has, it's more appropriately fitted into the 7th column rather than the 6th. Okay. Okay. Does everyone have this content that wants it?
Yes, sir.
Okay. So, moving forward then. Okay. It had talked about carbon 12 on the previous slide. Said carbon 14 exists, correct? Which it does. Okay. All right. So if you want examples of this, I suggest you write it down. I can. Okay. What is everything you can tell me about this that we just wrote down here? Okay. So what I want you to do is pick one of those forms of carbon, top, middle, or bottom. Okay? So with this, okay, protons, 6, that's right. It's neutral. How many electrons are there? Okay? And then how many neutrons does it have? Okay? We said the top one.
Because 10 minus 6 is 4.
Okay? So, moving forward then, usually I think the most common element to say the periodic table is based off of is this form, carbon 12. the most common type. What's true about all three of those numbers for carbon-12? They're all the same. Okay? The atomic number, 6. It's neutral, 6. So 6 from 12 also gives you 6. Okay? Then for a radioactive form of carbon, I believe that's radioactive as well, and that's what an isotope is. Okay? It means you have the same number of protons for any element, but the number of neutrons can vary. Okay? So, in this case, let's go ahead and do these. What's that number? What's the next one? I heard 6 and I heard 8. Which is it?
Oh, it's actually 8 because you just switched it.
All right.
The next one's 6.
There you go.
Oh, yeah, because you did. Oh.
Okay?
Oh.
So now,
I see what you did there. Tricky guys.
I want you to pick a D block element, okay? Which means somewhere in here, okay? Iron, that's fine. Okay? Okay, so off of the periodic table, it probably says 55.8, correct?
Yeah, you round up
Okay. But we're going to say this is radioactive. No. Okay? All right. So, how many protons does iron have? Okay, again, I can't stress that enough. This tells you what element it is because it's the atomic number. And it always increases by an exact increment of what? In other words, cobalt right next to it. Is it cobalt? Yeah. So cobalt right next to it increases by 1. Nickel right next to that increases by 1. 28, 29 for copper, 30 for zinc. Yes.
I do the 61. I get it's radioactive.
It's the atomic number.
It's atomic mass because we're going to say it's an isotope, just like those are. I said that earlier, but I said we're changing this to a radioactive form, which means we're going to say that it's 61.
How do you calculate to get it radioactive?
You don't just change it. Some elements are radioactive. We're just using this as an example.
So we don't need to know this?
No. No, we're not that advanced in chemistry.
Okay,
All right. So, it's neutral. So, how many electrons does it have?
35. 26.
Okay?
Neutral is.
So, in this radioactive form of iron, how many neutrons would it have?
35.
Okay? Okay? Is there any questions on how to determine protons, neutrons, and electrons? Okay? Now, you would have to be given this information if you're dealing with an isotope, okay? Because you can't have a partial neutron, okay? So that's why even if we're talking about what you see on the periodic table, 55.85, you would change that to this, 56. It's more common, stable form, okay? That's why if we're going to talk about an isotope, you have to be given that information. All right. So, are we ready to venture into bigger elements than past number 18?
No, we need to do that next. No, can we do one more, please? Next
Okay.
quarter, maybe.
We'll go ahead and do element 18 then, which is what? Okay. And then I suppose it's what, about 36, 37?
It says 39
Oh, 40, okay. So we'll just say 40. All right, so a Bohr model for argon will be as follows. Inside the nucleus, what do we see?
18.
P is 18 and 22.
Okay? Follow your slide rule, okay? It's a periodic function from the periodic table. It repeats itself over and over again. That's a periodic function. On your slide rule, the big number 1 is telling you what? The first energy level, okay? And what block is the only block in the first energy level?
S.
The S block. There's 4 blocks, S, P, D, and F. So we're going to put both of those in the S block, okay? Follow your slide rule. What comes next? Okay, what are we going to put in that second energy level? Okay, so 2s2, there it is. Then what? Okay, that's it. Okay,
We already got it. So
all right. So it's once you get past argon, it gets to be a little more tricky. Okay, because it's kind of like playing ping pong where you go back and forth getting past element 18. Okay, which I think you can handle that, because if we are going to talk about element number 20, okay, okay, we don't even have to change anything here. The only thing we're going to change is this. Okay? We already know these numbers add up to what?
18.
Okay? So now, if you kept going down on your slide rule, what is that telling you to do?
Third energy level for 6, but you.
No.
Wait, what? Fourth energy level?
Fourth energy level. Okay? For those of you who choose to listen, you're going to catch that right away, we hope. For others, you might not catch that.
there's 2.
Okay? So why are we putting this on here?
Because you need 4.
Because the slide rule tells you to do that, right?
It says 4.
Because that line goes through that big number 4, right? Okay? Look on your periodic table. What period is calcium in? Yeah, it's in the 4th period. Those are your horizontal rows. That is a period. There's 1 through 7 on there. Okay? So we just put both of them in there, and that's what you deal for, or that's how you deal with calcium. Okay. Any questions with this so far? No. These are going to get bigger, probably maybe as early as tomorrow. Eventually, we will be doing maybe this. You're going to go up to 82. Those of you who put the time and effort into this will probably be fine.
This is really easy.
Okay? All right?
Alright.
Left outside and left middle. Okay? Middle. Right side. Okay. Okay. So we'll catch up to you next time. We'll continue hunting the elements.